Perfect.
So this is an excellent talk to follow up on the one before. I'm also working on psychedelics. I'm working at the Charite. So do any of you know Charite here? It's a medical faculty in Berlin? Yeah. So I'm also having a neuroscience background, and we were studying together way back in Tübingen at the Max Planck Institute for Biological Cybernetics. And at that time, we didn't know what this meant, but we got into this because it sounded cool, biological cybernetics. So we want to understand the interface between humans and computers and things like that. But we have come a long way, and this is just to show that having studied the same thing, one of us went into research, and the other person went more into the industry side of things. And we would like to talk about today is how we can drive innovation through quantifying things that we never thought we could quantify before, and namely emotions. So this is an interview format. We would first pitch a little bit what we are going to talk about, and then we're going to throw the floor open, and you are allowed to ask any questions you feel like, whatever you're curious about. And this can only be as good as how curious you are. So feel free to ask us questions. So emotions is something that we all feel, we all experience, we all have, and it's something so intrinsically human that we are always curious about it. But the question is, how can we measure emotions? Because it is essential that emotions, as we understand, is a readout of human behavior. Why we behave a certain way in a certain situation, why we react, how our emotions are changing, depending on another person, depending on how we feel. So what is this all about? And to put this human behavior in context, there are two main things that we should understand at the very outset is we have perception and we have our perspectives. So what do I mean? So do any of you know the difference between perception and perspective? We hear about these words like interchangingly, yes? So how we think of it from neuroscience is perception is something that we interpret, we make a meaning of our world from our five senses. So this is something we can quantify, what we see, what we hear, what we are thinking, how our brain states are. We can quantify all that now, and we are going to talk about this during our interview. And the second thing is perspective, and perspective is very important for innovation because it is your point of view, it is your sense of proportion. So if you do not have the proper perspective, you cannot be curious or imaginative enough to come up with a solution that you're trying to solve through innovation. So these are the two pillars of human behavior, and the most complicated thing is to develop a perspective because perspective always changes. So this was back in 2008. As you see, we have a prominent politician here, and back then, the perspective was you reach out, you offer your hand, you try to communicate, you try to smile, and you try to kind of get to know the other person. This was the perspective in 2008. But 8 years later, we saw that the perspective changed. And what happened is the selfie culture came in, and so we all want to be now part of this experience. So this is how perspective changes, and therefore the question is, in this changing world, can we get a handle on our changing perspectives? Can we do that? And if so, how can we do it? And the answer is, we can perhaps try to understand how we think, how we form, how our emotions are through emotion analytics. So that's why here we are two of us. I'm still at the university, and this is a platform I have to communicate between the industry and research in academia. And this is Sensory.eu, whereas I invited Elvira because she's doing actual market research and reaching out to people, and she's working at iMotions in Copenhagen. And in the next half, she's going to tell you more about what iMotions do, and then we are going to follow up with a question and answer session. So, Elvira, welcome.
Thank you so much. So, as Prateep already said, I'm a neuroscientist by training, but I'm also a product specialist at iMotions. And iMotions is a software that allows you to measure behavior empirically by combining different behavioral data streams, such as eye tracking, facial expressions, or cognitive measures such as EEG, where we measure the electric activity of the brain. And my responsibility is to help customers and our clients who come from various fields such as automotive industry, but also neuroscience or economics, to actually understand human behavior on an empirical level. And so we consult them on which kind of sensors or behavioral measures to use. So what is iMotions? iMotions is a software platform, as I already said, that combines different data streams, and we're the only one who can do that live. So you can live see how different emotional measures or behavioral measures are integrated and synchronized. So you can see how eye tracking, for example, so where we pay our attention to visual attention, and for example, arousal are synchronized and play together in order to understand human behavior much, much better. And this gives you a really good handle on how humans behave, actually. So this is a little bit of an overview so that you get a feel of what kind of measures you can actually combine. So we can combine cognitive measures, as I already mentioned, such as EEG, where we measure brain oscillations, and we get a handle on cognitive processes, such as workload or engagement. But we also integrate biometric measures such as eye tracking for visual attention, GSR, galvanic skin response, to understand arousal or stress levels, but also facial expressions to understand emotional responses. And then, of course, we also integrate physiological measures such as respiration, heart rate, and muscle movement. We also offer, and this is really important for commercial clients, a stimulus presentation tool. So we bring actually science to the commercial sector in order to making it easy to actually integrate stimuli or to set up experiments, and then give them some kind of handle also on the analysis side. So this is a short example in order to visualize and illustrate what we actually do. So this is an experiment in a real-life environment. It's in a supermarket. The respondents have a task to find a certain toy, in this case Lego, because we're in Denmark. And what we offer is basically that we take this very complicated 3D visual pattern of your eyes. If you can start the video, please. And you will see this is, you can see this is a real-life recording, and then we map that complex eye movement onto a 2D image. And what this allows you is actually to later on really easily visualize where the visual attention of that particular person that was looking for this particular toy lied. So here you can see how this is done. So you can see a heat map of the visual attention, and it becomes really clear where the focus of attention was in that case. And by combining it with the arousal measure of galvanic skin response, we can actually see when the person was stressed. So the person was much more stressed when they had less information about what they were looking for, and that they then decreased. So by combining different biometric measures, we actually get a better handle on understanding human behavior. So in this case, arousal and attention. I'm handing it over back to you.
Yeah, so we have heard a lot about these things now, like you hear a lot about visual attention and things like that, but I think the reason we wanted to have this interview is to come to you very openly and talk about the challenges and the opportunities of this technology. So the first question that I have for you is, why is this relevant? Why is it relevant to understand human behavior for research, for innovation and development of products?
Yeah, so if you look at the trends lately in technology, for example, virtual reality, augmented reality, we can see that the human brain was actually the model used to produce these, right? So, for example, neural networks or deep learning algorithms that are basically modeled on the base of how the brain works. But also, if we think about usability of applications or any kind of product that interacts with humans, we need to understand how humans behave in order to improve and actually get a connection to the human who is using that product. So whether this is like a technology that interacts like chatbots, for example, or an application, a website, or even in the automotive industry, if it's the dashboard of a car, we need to understand what humans pay attention to and how they behave in the actual moment, in the moment of truth, rather than relying on verbal responses or surveys, for example.
Yeah, it's surprising that how much of this behavior is actually subconscious that we are not really aware of.
Yeah.
Anyone working on user-centered innovation here? We hear a lot about this right now, design thinking, user-centered. Do we understand human behavior? It's one of the most random things on this planet is human behavior. Yeah? Can we understand human? No, I don't understand my behavior at times, so I guess it's difficult to understand others. There are challenges, of course, but we are getting there to understand this at a much parametric level using all these techniques. So the next is, as I was telling, this is very diverse. There is a randomness in this. How reliably can we measure human behavior?
Yeah, so I mean, we know best, coming from research, that we had methods already 10 years ago on how to measure certain things, for example, visual attention or certain stress levels. But of course, there was a couple of hiccups, and because we needed a lot of different softwares, we needed complicated technology in order to do so. And now, by having the opportunity to actually have a user-friendly software or user-friendly also hardware devices that everyone can use, we can actually measure behavior on an empirical level, rather, as I already said, with verbal responses. So I think it's important to also incorporate empirical measures in order to reliably measure human behavior. And as you already mentioned, Prateep, a lot of the behavior that we expose or that we show is often non-conscious. So we can't even really articulate what happened in certain situations. We can reflect on it and try to memorize what we did and then rationalize it, but that's not necessarily the same.
Thanks. Yeah, I can tell you for one thing that if you see an offer outside and it says 50% off, you and I will get excited to the same level. This is intrinsic. This is just being human. But what we do with that 50% offer is what is at the second level. This is subjective. And what we try to understand is what are the parameters which are objective and intrinsic as humans, and can we quantify these parameters? Which brings us to the next question. Is what can we understand then from this human behavior that we can quantify now?
Yeah, I think we have to be very careful, and we know from research we are very careful in how to interpret those signals, right? So we know that we can measure things, concepts such as attention or such as workload, stress, arousal, and we're getting slowly to investigating more complex concepts such as motivation or approach. And so by continuously progressing within the technology, but also in our understanding, we can actually tap into more complex concepts. But as of now, of course, there are some limitations.
So I'm sure you have some questions. Do you have any questions? Hold on, just a second, because we have one more questions, and then we will throw the floor open to the audience. And the last question is in this round is we have talked about the opportunities. Now we would like to know what are the limitations of this kind of human behavioral research, which could perhaps pave the way to also having a better future for biometrics.
Yeah. So, of course, all those measures originated in lab setups. So still, as of now, the most controlled setup is in a lab setup or in a setup that we can control. And we're moving towards testing in a real-life environment, in real-life situations, actually capturing the actual behavior that is not artificially induced as we would do it in a lab, right? So, but still, the technology, the way it's built, it works best in a controlled environment. I think the other important aspect is to understand that we still have to wear sensors to do so. This is not the case for facial expressions, where we just need a facial, like a camera, in order to record our face, and then the algorithm runs through and basically classifies your facial expressions. But with all other measures, we still have to wear devices, and of course, this is invasive. And not everyone feels comfortable. We also are biased once we wear sensors. We know we are in a testing situations, and that is for sure a limitation. And this is where biometrics and human behavior research is moving towards, to basically come up with technologies where we actually don't have to wear sensors, where we can do it from a distance, where we can do it maybe through the internet or through long distances. So yeah, this is where the limitation lies.
So that's also the future.
I hope so.
So before we leave the audience, take the audience questions, I would like to announce two things. So once we have tonight at 5 o'clock, we will be at the Ask Me Anything session. And secondly, today evening, we are going to do a satellite event at Beta House at Moritzplatz. So there we are going to do much more hands-on stuff. So if any of you are curious about how your brainwaves are, how you can record your skin responses to arousal, or also combine this with face tracking, eye tracking, as well as facial expressions, please come by. We will be really happy to have you over. We start at 8 this evening. And we look forward to all of you, and we would give you a chance to actually try these things out. So we will also kind of come up with a play test.
Yeah, exactly.
Yeah, so this would be fun to see like what you're really thinking. We would know a lot about you. If you want, you can also like record from us.
Yeah.
Okay, so questions.
Okay, I'll first here. Catch.
Hello. How much is human behavior hereditary versus environmentally influenced?
So I think there are certain principles where we know, and this is also what we play with, of course, where we know that certain stress responses are elicited. For example, we know, for example, with highly sexual or highly violent contact, we expect certain behaviors. And this is for sure based on evolution and genetic makeup, right? But then, of course, depending on which cultural background you have or also personal experience, there are some variations towards that. I think a good example, for example, is facial expressions. So different cultures have different ways of expressing the same emotion, right? And this is also a limitation and also something that, for example, we have to work with, where we have to improve to basically classify these correctly based on gender, cultural background, or age, for example, as well.
Yeah, that's a good question. I think culture plays a big role. So if you're coming from India or if you're coming from Germany and I say that I want to give you 1 million euros, how would you like to have it? Immediately or over 4 years? Your answers would be different. It's really dependent on a lot of factors, but some things are intrinsic, and therefore we would like to know these things. So next question.
Toss it that way. Simply one of the hands, whichever one. You could stand up and throw it. What?
So you have probably collected a lot of data. You have just shown us that there's a variety of biometrics. So I'm interested if you could tell us a little bit more about which of those are most predictive of, for example, psychological health on the one hand. And I'm also interested in hearing if there's anything non-intrusive that you're also looking at, where you're not so hardware dependent.
Yeah. So in terms of non-invasive, it's definitely at the moment facial expressions, because there you just need a webcam. We integrate an algorithm that basically classifies the facial expressions based on the FACS system, which is an established system for facial expressions. And that can be indicative of certain psychiatric disorders, or, for example, reactions such as empathy. For example, we use that often for research projects where we have to look into empathy. On the other hand, I think in an academic context, EEG, so measuring brain oscillations towards a certain task, but also towards a certain pathology, is probably the most indicative. And then also eye tracking. We know from eye tracking that there are different patterns depending on different disorders. For example, Parkinson, we know that the eye tracking patterns and the saccades are different than in a healthy than in the healthy population. Of course, more physiological measures such as galvanic skin response or respiration, they would be less indicative for those specific, for this specific context.
There was one question here, right? So maybe you can just speak loud and then.
Okay, I understand that using this method, like eye tracking, produce a lot of short data. It's like a huge amount of data. So I'm wondering how you manage to filter this data and to have a clear answer,
especially when you want to use this data for empirical research, that you need like a clear result.
Yeah. So
can I shortly, like for the rest of the audience?
Yeah.
So she asked, like, we have a lot of data which we collect through eye tracking. How can we make sense of this data and come up with something which is empirical about it?
Yeah, this is also that my job at iMotions. I have to consult which kind of metrics, for example, are important to understand. So, for example, when we look at fixations, we would look at time to first fixate, which gives a good indication of what is salient. That can be based on context or on physical properties. Red, for example, is a salient color. So if you have a visual imagery and you have something red in there, you can be pretty sure that people fixate there quite quickly or first. We could also look at number of saccades. We can also look at time spent in order to understand where is a sustained attention. So there are a couple of metrics that you can extract based on the algorithms that we use that will then allow you to better understand the eye tracking patterns that we extract.
There's a question up front that, yeah,
And this one in the back, I think.
catch.
Thank you. My question is in regards to how interested are big corporates into all this behavioral research, like onto different kind of stimuli. Are they interested in neuromarketing and or neuropolitics? Do you work with them in iMotions?
Yes, we actually work with a couple of very big companies, such as Unilever, for example, but also automotive industry. And there's a huge range. It starts from sensory testing up to product testing, package testing, of course, neuromarketing to some degree, but also a lot of R&D. For example, in the automotive industry, it's really important to initiate new mechanisms. For example, how can we detect when a driver gets really drowsy or tired? Or how does a dashboard have to be designed in order for you to extract important information, but without being too distractive, for example? So this is, for example, one part. Then we do a lot of course, website usability testing for sure. So these are the main topics, I would say. A lot of R&D at the moment.
You yourself, you do the interpretation of the kind of information when communicating with the corporates?
Yes. So there can be two parts. So either we teach them how to use the software and help them to build an in-house lab. This is the final goal, actually. But in the beginning, we help them out with service projects where we help them to set up the appropriate studies so they actually test what they want to test, and then help them with the analysis and the interpretation of the results. Yes, and this is my job, more or less. We're 60 people. We have an office in Copenhagen where we have 40. We're sitting together with the developers, which is really nice. And then we have a team in Boston who is basically catering to the American or the US market. And we work together with Harvard, MIT, Stanford, UCLA, some of the nice schools in order to, yeah.
One last question over here on this. Catch.
Okay, I do have a product development background, and you talked about the difficulty to measure without being too interruptive. And I was wondering if in the end, maybe in 10 years, there could be something like digital empathy. Do you feel that that could be something you're measuring and having a result that makes machines more empathetic?
That is a very good but also complex question. I think the trend is towards that. Of course, based on our data, as with the chatbots, we try to use our results in order to basically inform maybe new algorithms. We don't do that at the moment. We are more on the actual product side, not necessarily working with IT in that sense. But this is definitely something that a lot of people are interested in also when they come, for example, from augmented reality, right? Where there's like the connection between the human and the actual, computational aspect. So I hope it will go into that direction, but I think we're quite far away yet from it, actually.
Okay, thank you very much for all the questions. As I said, we will be at the Ask Me Anything at 5 p.m., so please come by. And we are around today and at the satellite event again. Thank you very much.
Thank you.
I will give a hand clap.